So good morning everyone, and it's a pleasure to be here today. So my name is Jewell, the Vice President and General Manager of EMEA for Brocade. And my team have told me to inject some energy into this. So I'm going to give some counterpoint to some of the digital journey that you've seen. So I'm going to want to show of hands to start with. So first of all, let me guess what was for dinner last night. Was it chicken or beef? Chicken or beef? Beef. Yeah, always is. The other thing I want to know is how many times have you heard Uber mentioned in presentations? How many times have you heard Airbnb mentioned? How many times has the word digital been used? Now, I work for a Californian Silicon Valley-based company, so I'm going to use words like leverage, which I apologize for up front. I might also say router. I mean router. I apologize for those things up front. So what am I going to try and talk about today? What I'm going to try and talk about is the point to counterpoint from the digital transformation and what it means for you guys in the room. I'm also going to try and give you something to take away except from fear and confusion. So I'm actually going to try and give you something to take away, which is a step process. Now, this step process was something I wish I actually created it, my team created it, that I actually patented, because it's now being actually used by Accenture. So the piece of information that we charge nothing for, you're probably going to get charged a lot of money if you go to Accenture for. It's actually used by IBM GTS in the UK, and it's actually being used by Amazon in places as well, Amazon Web Services. So this five-step model is going to become quite pervasive in what we talk about. So how many different types of businesses do you think there are in the world? Anyone want to guess? How many different types of businesses? 50, 40, 10,000, 20,000? The answer is actually there's 40,000 different types of unique businesses. You can consolidate those into about 15, when you can look at central government, you can look at manufacturing, services, etc., etc. So out of the 40,000 different types of businesses, how many unicorns have appeared in the last 10 years? How many Ubers and Airbnbs and these kind of things have appeared in the last 10 years? Does anybody know? It's about 20. It's about 20. It's about 15 to 20 organizations in the last 10 years have revolutionized on a digital basis. At the peak of the Industrial Revolution, how many companies do you think revolutionized in a 10-year period? 20. No. It was a lot more. It was 100. And this is a great part of the country to talk about the Industrial Revolution. Some could argue it started in this very city. So when we think that we talk about everything changes and the world is different, and people will quote about the number of emails that get sent, the number of mobile devices in the world, the threat that we have, actually, the thing that limits change is actually humans. As human behaviors, we can only change as quick as we want, or as quick as our brains allow us to. Behavioral change, I'm sure there's some psychology people in this room, is the hardest thing to change. Some people will argue that you can't change. So when we talk about the digital transformation, which I am going to talk about, and I'm going to use all the buzzwords, and I probably will have an Uber slide in here because we feel bad. If you come from the Valley and don't have an Uber slide, you feel like you're missing out. Let's put it into context that the speed of change is limited by human ability to change. What we've created in the digital transformation with the technology shift and the rise of cloud is the ability to change quicker. It doesn't mean that we will, but we have the ability to change quicker. So I want you to bear that in mind when we go through this. So delivering the digital institution. All change. Or is it? The biggest question, I think, is what does digital mean to you? So who here can see forward more than 5 years with technology? Has anyone can tell me where you'll be in 5 years with technology? Anyone give me 3 years? A year? I hope somebody's got a year. That seems to be a horizon at the minute. We see and we talk in our daily lives, and as a business we talk about where we see ourselves in a year. As a public company, we're always in the most important quarter in our company history, so anyone's worked for a public company will be familiar with that. So we can normally see about a year, 2 years ahead. But we talk about strategies which are 5, 6, 7 years ahead. And what it means is it leads us to believe that we can't make these first steps. We get paralyzed. And there's certainly been a bit of paralytic behavior in the market over the last 2 to 3 years. The good news is that institutions such as yourself are in a no different place than banks, or in a no different place than hospitals, or a no different place than central government. There is not anyone out there that is making these huge sways to digital transformation any quicker than you guys. So you should feel happy that everyone roughly is in the same position. And we believe that the tools we're going to give you to change, or can allude to you to change, will help you start making these steps. The other thing, a bit of controversy on this, is How much revenue do you think anyone in the room from Amazon Web Services, before I say that statement? We're not going to tell me now if you are anyway, but anyway. Hands up, who's an Amazon Prime user? Great service. I think we all agree, fantastic service. My behavior has changed using Amazon Prime. I can now stream, I can now download, I travel a lot, so I get to see shows, I get the box sets, fantastic television shows, free delivery, access to store stuff in the cloud. Perfect, perfect for what I use. Do you know that you're counted as an Amazon Web Services business user in their revenue roll-up? Well, you are. So they do 1.2 billion in EMEA of Amazon Web Services. That was the last stated figures they did. Could be a lot more by now. What percentage do you think is Amazon Prime? I don't know because they don't tell us. But it's a lot. You figure it out. How many people that you know, you figure a lot. So how many people are actually making this huge swage to Google, Amazon, cloud technologies, wholesale? Not many. We have problems, particularly in this country, particularly in EMEA. One of the biggest problems, and I'm sure our Gartner colleague could talk a lot about this, data sovereignty. Massive problem. Next problem, governance. A lot of you report to boards, I'm sure, on those boards. If you said, I'm going to take all my infrastructure and throw the whole thing to Amazon, they might think that's a good idea because lots of people think that's a good idea. Has anyone looked at the pragmatic steps you need to take to do that? Huge, scary, difficult. And there's another problem. Has anyone costed doing that? Do you think that's cheaper than you can do it? No. We have a fiscal inhibitor, which no one wants to talk about. Yes, it can give you flexibility. Yes, it can give you dynamism. Yes, it can give you, help you in an unpredictable world. But it doesn't necessarily give you the panacea that you believe it can. Now, does that mean we're anti-cloud? Of course not. Amazon is a fantastic company and a fantastic partner of us. Our virtual router solution is their #1 selling virtual software product. If you spin up machines with Amazon and you need to route between the two machines, it downloads an instance of our virtual router, a product called Viata. We sell our virtual ADC, our traffic manager, our load balancer through them. We have a fantastic relationship. They're one of our largest fiber channel and top-of-rack customers in the world. And there is an inevitability that companies like Amazon and Google and Azure will make and take that transition. But I wanted to make the point is not everything will move to what we call the public cloud. The problem we have is what we're calling the cost of digital divergence. So, and the simple summary here is the cost of doing nothing, the cost of continuing on what you're doing, but more, the cost of being confused is way more than the cost of doing something. And we can prove this actually pretty clearly through the 5-step model. One thing we don't talk about, and I'm going to talk about that because, as it says, I'm a sales guy and I sell networking products. By the way, if you don't know what Brocade do, we are a networking company. We don't make printer cartridges. We don't make servers. We don't charge you a tax for the honor of using our product every year. We make networking products. And our brand is not as explicitly known because we're probably, difficult thing to say the world's best, but certainly one of the world's leading hardware OEM vendors. So if you buy a storage array from EMC or HDS or HP or IBM, it will be our products behind it, connecting that together in a fiber channel world. And we also OEM our IP products a lot. So a lot of people that buy IP storage network, NAS attached, those kind of things, will have our connectivity behind. Everyone forgets about the network and believes that the move to the cloud can sort everything out. Anyone here got an old clunky Unix system with the code's been written over 20 years by 20 different people and nobody really knows what it's doing, but it's kind of running core applications? Pretty much every bank in the world has that. Have the conversation about Amazon or Google taking that on. How long do you think that conversation lasts? No, but I can sell you this. I can sell you online backup, but I don't want to touch this. But that's the bit I need help with. And the Gartner phrase of bimodal, I think, is one of the most important phrases to use. That we have to get used in the next phase of running two different worlds. We have the legacy, and it's unfair to call it legacy because it actually works and it delivers a service. And we have the future. And getting that balance right is critically important. So the transformation tipping point, I said it was a Silicon Valley presentation, so we have to talk about tipping points, and I have to have graphs that go this way. So what have we done with IT over the last 5 years? Well, the last 5 years, or the last 10 years, has really been the consolidation and rationalization. Predominantly driven by the invention of virtualization, of the server virtualization, the ability driven by the hypervisor vendors, that you no longer need single applications, or you can virtualize those machines and you can have them across multiple areas in a dynamic environment to utilize the compute capacity that you have purchased. And we then get to a point where virtualization has driven you down of a cost saving or a potential cost saving. A lot of people I speak to about the VMware license fees don't often say it's a cost saving. But a potential cost saving of reducing your compute spend. But at that time, the demand has gone up because of the all change thing that we talk about, the increased email, the increased access from mobile networks, the increased requirement for your students, increasing requirements from your research departments. I bet all of you love providing networks to research departments because they never play with them, do they? They never start messing around with them. We know that from fact because obviously CERN is one of our largest clients, and so quite a demanding client in how they look at our operating system. So in order to continue down this, when you've virtualized pretty much everything you can, when you've looked at maybe offloading a certain amount to the cloud, the easy stuff to the cloud, which is a great idea, maybe backup or tier 3 storage or some kind of, you might have bought some cloud services and trying to build your own. Predominant in our world is Salesforce.com. Every single commercial entity in the world, pretty much of any scale, will use that as opposed to building their own customer and sales platform. How are you going to continue this journey? We are going to have to look at automation. It is impossible now to get any more drive from the network or from the compute or from the storage layer without considering automation. And once we've started automation, we have to have some form of orchestration. And these were those lovely 3 words of SDN come in. Has anyone tried to buy SDN? Oh, good. We have some opportunity. It's a very difficult thing to buy because it's very far to the right. I think in the Gartner phrase, we're in the trough of disillusionment with SDN, so we'll be climbing out of that pretty soon. But it is inevitable that the network and storage will virtualize in the same way the compute layer has. There is an inevitability about that. So how do we start that process? So for the tripping point now, the point that I wanted to make on this slide, which I forgot to make, is there's now diminishing returns from continuing where you are. So basically, the relevance gap will continue, but you can no longer provide either a cost reduction or an agility unless we start looking at automation and orchestration controls. It will be impossible for you to do that. And so the alternative is to go to the cloud, because the cloud has that. Or does it? To a certain extent it does, to a certain extent it doesn't. And this is what's called the agility gap. And this you can compute. You can calculate this. You can calculate the cost of doing nothing being way more important than the cost of doing something. So if we take anything away from the presentation for you guys, we need to look at getting you on the path to automating some kind of infrastructure and then ability to orchestrate some kind of infrastructure. And in a nutshell, it's taking the attributes of a cloud service provider and trying to become, to a certain extent, a cloud service provider of your own. Now, the conditions for doing that are quite simple. You will only do it if you can do it better or cheaper than the external market. Very simple. If local cloud service provider, a hyperscale provider can do it better, cheaper, faster than you can, you should be giving them that business. One thing that underlines that, though, is governance. Can they do it and meet the governance that you have? And we'll talk about security a little bit, another spin on security as we go through this. So it's time for a new IP. So this is a phrase that we use, a new IP. Now, new IP isn't new intellectual property. It isn't something you can actually buy. It's a concept of changing the way that the network operates in order to provide some of the flexibility and the cloud-like deliverables that we believe that you need. So the first thing that we need to be able to do is we've got to recognize that networks that we designed, and I will get to get too technical, used to be based on custom ASICs. So companies like Brocade used to build their own chipsets. And we're meant to be open because it's Ethernet and IP. Do you think our systems are open? Of course they're not. No one, any network vendor that stands up here and says he has an open system in hardware is frankly, shouldn't be here. It's a closed operating system. It becomes open at the Ethernet port because Ethernet can connect to the transport mechanism to anything else. So what we need to do is we need to recognize that the networks were never designed to do what we're now asking them to do. Virtualization concept to a network is not very good. Networks are quite static. Virtualization is completely dynamic. I love it when people tell me they absolutely have a control over their network, so they understand what their virtual machine network is doing. You can't, by the nature of a virtual machine, understand what that's doing. You can report historically on it, but to plan what it's doing is impossible. Does anyone believe it? And again, VMware, a great partner. Does anyone believe in this room that when VMware come in and say, you don't need to worry about the underlay, just put NSX on top, it'll be fine? Again, that's not quite true. And I think it's shown in the success that they've had how untrue that statement is. And by the way, we actually believe that NSX is a very good overlay technology. We have a lot of NSX deployments which we're working on. It's a very, very good technology. So we need to look at what the conditions of the network are, and we need to change them. So the 5 fundamentals that you need, and there's always been the same, it has to have zero downtime. So zero downtime means it needs to be designed from day one to be redundant. Excuse me. It must have some level of automation and analytics. Because the workloads are no longer static, it is no longer you building a series of servers in a server room. When do server rooms turn to data centers, by the way? We started, it used to be computer rooms and server rooms and data centers. You have to be able to have availability on that network to meet the capacity known and unknown to a certain extent. So it has to be more flexible than a static environment. And the only way you can really do that is making it software enabled. And the key thing here is it needs to be open. Or actually, I'm going to contradict myself. People don't really buy open. Nobody actually cares if something is open, except your high-end research departments. They love open because it's open source, open code, they get their hands dirty. What you don't want is closed. So you want the attributes of an open environment, but no one wants to run an open source piece of code in a live production or revenue generating or support mechanism network. That's not a sensible thing to do. And the example is Red Hat. You know, Red Hat is a multiple billion-dollar company which effectively hardens open source. That's what you'll see the network market become. So the 5 steps. So the first step that we believe that you need to do is audit what you have. Do you fundamentally understand what you have? Now, this seems like an obvious one. Align with the business. Where does the network inhibit the business? Does it give you the flexibility? Does it give you the capacity? For instance, if you purchase a network, a new network infrastructure, which you guys do a lot. I mean, networks are incredibly important to you guys. You go through a tender process. You choose on features and benefits and cost. Absolutely fine thing to do. You deploy it. You have overcapacity for about a year, if you're lucky, in that network. But you have a return on investment of 5 years, and then you run it for 4 years suboptimal. Because the chancellor's not going to give you any more money for a new network. Everyone's screaming at you that you haven't got capacity. And this seems to be a common thread in most organizations that we speak to. So if you align to the business and understand how you can move with them, we can avoid some of those pitfalls. The other thing is you've got a plan with change in mind. Trying to nail up absolutely what you'll see in the next 5-year roadmap. It amazes me when my sales guys ask me to come out and say, and we bring loads of technical people, say, can you give them a 5-year roadmap? No. I can tell you what we're developing. I can tell you what our suppliers are providing, whether it's Cavium, Broadcom, Intel, more and more. I can tell you that where photonic networking is going to be. I can tell you where arrays are going to be. But I can't give you an absolute 5-year roadmap. And anyone that says they can, it's not true. They can give you indications of what technologies they think will be available. And the other thing is it's got to be fit for purpose today. It still surprises me the amount of people that still invest in technology which isn't fit for purpose today. And there's 2 extremes. One, it's suboptimal, i.e. products that were being used to do something they were never designed to do. Or the other one, it's just way too early. Just way too early. And our industry is at fault. My industry is at fault in that because we bring out things a little bit too early. SDN, or NFV, being a prime example. So this is a comment from a large service provider, solar technology manufacturer. 50% cost reductions returned on just by understanding and improving uptime and reducing power. So designing a network that was fit for purpose, not and aligned to the business as opposed to something different to that. The next piece is we need to automate. So, and I'm sure lots of you would want to automate the network. Most of my job is meeting with customers, CIOs. I'm lucky enough to do that on a constant basis. I was with banks earlier in the week, a big debate with a large UK bank, where the CIO and the CDO, there was about an hour debate trying to figure out what software-defined networking was. So we finally got 2 words out of it, which we've seen here today. Let's say it's about automation of the network and orchestration of the network. Can we agree it's those 2 things? Yes. What do you want to automate? I don't know. Okay. What do you want to orchestrate? We thought about that, we're not quite sure. But we have to have SDN. Okay. This is going to be a tough sell. So you may as well just put in an open daylight controller and go and get a load of DevOps people to do that for you. Oh, I can't afford DevOps people. Okay. But, you know, I've got 400 Cisco CCIE, CCNAs, and CDAs spread across my world. Can they program? No. Okay. So you can see some of the problems we have in taking people through the future because they're simply looking too far ahead. When we went through this model of going, why don't we just look and audit at what you got, figure out making sure you're actually aligned to the business, and this is a piece of work that we do. We actually work with the business and the IT department to figure that out. And then optimize for applications to cloud. This is like a turkey voting for Christmas, to a certain extent, because most of the recommendations that come out of phase 2 is moving workloads to the cloud. We have a decent insight to the cloud service provider and XSP market. Why? Because the cloud service provider and XSP and hyperscales are the largest procurers in the world of our technology. Outside of the US government, the biggest network spends come from telco and CSP. So we know what they have, we know what they're trying to do. So we look at the workloads that you can easily move. And people find that quite shocking, that you go, oh, you don't want to build server farm and connect to that. No, you may as well offload that. But it's the only way that we can get you down this piece. The other thing is when you move to the cloud, one of the things that we're noticing is there's lots of free things in the cloud. Have you noticed how these free things exist? If you buy this base service, you get this free. I don't know how familiar the room is on the concept of a load balancer or what we call an application switch, a layer 4, layer 7 switch. Is the audience familiar with that? It's kind of a prerequisite for any web transaction. So going back to my favorite topic, Amazon. Anyone ever had their credit card page have to refresh on Amazon? Doesn't happen. Once they know you're on the credit card page or click to buy, yeah, all of a sudden there's a device which is saying, right, give them all the service in the world because they're about to spend money with me. Mr. Bezos wants another piece of, he wants another dollar in his 500 million or 500 billion or whatever he's got, reportedly. So you can tell when you do a web transaction, and that's a retail web transaction, what guys are using those kind of technologies. You can tell in call centers, whether it's a clearing call center or a student service you're trying to give. You can tell the ones which are prioritizing traffic to that. The cloud will give you that for nothing because they want your workload. So if you move your workload into the cloud and you now have this free option of the traffic manager, and you decide you want to move that workload to another cloud, how are you going to do that? You're kind of nailed up, aren't you? They kind of got you stuck. So we've got to be careful that when we do this auditing, that some of these free things at the minute are a way of enticing people into sticking with them. Because the beauty of the cloud for all of us is it's completely transposable. And I use that word transposable on purpose. In that you should be able to, like any utility, move things dynamically even around from the different cloud providers. Now, they've recognized that, and they don't want to do that as much as if you use whichever energy company. Do they really want you to move? Not really. The government keeps saying they're making it easier. I don't think they are. Or mobile phone provider. Anyone gone through that recently? Meant to be a slick process now. Can I port my number? Well, you can, but okay. You're going down this line. So we need to be careful that you are moving workloads in a pure environment, but keeping hold of certain controls so you don't get stuck in an unproductive cloud relationship later down the line. As much as we equally say you shouldn't get stuck with an unproductive hardware decision. If you're going to build a private data center, why would you go down a proprietary route? Why would you do that? Why would you go down a closed proprietary route? Because the market leader says you should? That's a good idea. Would you buy a car that you could only fill up from a BP garage? Probably not. Would you buy a network which is closed to everyone else except its own overlay? No. That would be a silly thing to do. The next thing is a simple one, is optimize for speed and efficiency. We sometimes forget, networking still is about moving packets around a network, or frames if it's fiber channel. So we still need to consider the speed and efficiency. What we've seen here through the optimization curve is a lot of people forget. Unfortunately, networking can be complicated, and some of the best practices of networking have been lost a little bit. We've seen, there are products which were never designed for certain tasks, and I'm sure if I asked all of you honestly, there's some in your network. We saw a data center for a university built completely on Netgear. Oh dear. Now, nothing wrong with a Netgear product. I use them extensively in my house. I'm not sure I would base a research network on Netgear. It's not designed to do that. Still a very good product. So we still have some of this piece. Now, the way that you can do this is something we come up with, the concept of fabrics. So we have the concept of Ethernet fabrics and storage fabrics. So a fabric network is effectively a very simple way of making one big virtual switch. So instead of having these different segmentation points and worrying about routing and VLAN segmentation and the complexities of the network, the easiest thing to do is to be able to connect lots of switches together and make them operate like one big backplane switch with shared intelligence, to take some of that lift away, and then making sure that the speed and density is correct in that space. Another thing we've seen in this space, and predominantly from the cloud service providers, is that data centers are no longer built exclusively on the big, heavy chassis piece. There's certainly a move for people to use what we call pizza box, the smaller switches, to build those networks together. So if you went to an Amazon or a Google, what you would see is pod designs very much like that. Very rarely do you see huge racks of high-density chassis switches anymore, except for the core routing functionality of a network. So we need to stay current and remember that networks still need to be designed. The analogy I use is saying SDN solves networking problems is like saying electric cars solve congestion. They don't. SDN solves a whole other set of things which are really cool, and electric cars solve a lot of things which are really cool, but they don't make congestion better. Good road design makes congestion better. Okay. So, stage 4. Now here's a slightly controversial bit. Stage 1 and 2 are really important, and probably the only steps you need. Step 3, some of you will get to. Step 4 and 5 will be replaced in the horizon with a new step 1 and 2. We've just got to get used to that. We all agreed that we can't see further ahead than 1 or 2 years. Maybe 1 year at most. So when we talk about this journey, set out on the right path, but just accept that we'll be continually going through steps 1 and 2. And if you look back through how the industry's changed, it's just kept going through step 1 and 2. No one ever achieves step 5. We've never been right yet. Never been right yet. Now, Gartner might argue with me that they got it right a few times, but I would love to see any evidence of somebody giving a 5-year prediction of things happening. Very rarely right in our industry. In other industries, yes. In ours, no. And here's the goal. The goal is to be a service provider within an organization, an overused word. To be a cloud service provider within an organization is a better word. To have an always-on optimized IT service. These things can only flow from the base infrastructure being correct. And we're adamant that if we get steps 1 and 2 right, actually the move to 3, 4, or whether it's a new 1, 2, becomes a lot easier. So, summary of the transformation. Discover, optimize, virtualize, analyze, and allow yourself to orchestrate. We have some customers which have gone very thoughtfully all the way down to 5. We have some customers which strict continually 1 and 2 and 3, but we do believe this is a framework that can be used again and again and again to assess your readiness to align to the business. So about Brocade, just to finish up, and then I can take some questions or give them some time for coffee. The first thing is what people don't know about us. So what I'm proud to announce is 2 things which are really important, especially for a UK audience. We have the biggest number of software engineers in the networking vendor space in the UK. So we have now 180 software programming engineers. These are not people programming our network operating system. These are people programming open daylight controllers, our Viata V router, and more importantly, on the Cambridge Science Park, we acquired a UK company, which got acquired by Riverbed, and we bought it, called Zeus, which was the world's first virtual traffic manager, so a software equivalent to an F5 device. So we're very proud on that basis. 26% of our R&D goes into pure software engineering now. So are we trying to become a software business? That's a hard lift for any network vendor up here to say they want to be a hardware business. What we are is becoming a software, move from being a hardware business, sorry, we're becoming a software-led business. So certainly you'll see from us a lot more. So what should we be known for? So the world's most downloaded virtual router. And what is a virtual router? I'm sure we can figure it out. It's a router that's virtual. What does it do? It replaces, in the core of a network, the need to buy an expensive border router. What's it ultimately going to do? Most of you will have an integrated services router. I called it router, didn't I? Damn, sorry. Router. Integrated services router at the edge of a network. You've got one in your home, I'm sure you have. You'll see them at the edge of networks, dominated by one company for the last, since they existed. You also have compute power at the edge of that network. So why are you putting in normally a $1,500, sometimes $2,500 device when you've already got compute power at the edge of that network? Why don't you just make that an application on the server? Or even better than that, why does the telco not even have that as a virtual customer edge back in his data center and then just provide you a wire? Don't even need to put anything at the edge. Don't even need software at the edge. You can do that back in the data center. So the expense, the management, the truck rolls of managing edge devices for telcos and SPs, huge. They don't want to do it. So what we're working on there is with AT&T. AT&T awarded us a contract, and it was called Domain 2.0, and we are the chosen provider of their edge router. So their statement is they don't want to put any more physical routers into customer premise. They just want to, bang, download a piece of software, running it. Now, why can we now do that? We can now do that because something has happened which people didn't understand. Intel now have network-capable chipsets. So it's not only the processing power, it's the bandwidth that they can push. So the bandwidth that the new chipsets can push, I should have put a slide up, is massive. So you are going to see more and more and more applications running in an x86 environment for networking. Some of you might have heard about a company called Arista. Arista is a great company, with some very clever people behind it. Nothing designed by them at all. The whole solution is based on industry-standard chipsets from Broadcom. Most of our products, 85% of our products, are now based on industry standard from Intel, Broadcom, Cavium. So we no longer are in the hardware design game of making custom ASICs, except for the big core routers and fiber channel switches. The next thing, the first open daylight controller. What is open daylight? Open daylight is the open foundation which is trying to bring to the market open code to create software-defined networking controllers. How many of these sold? Quite a few. Are they deployed in anger in tier 1 banks? No. Do we believe that the open daylight SDN controller will be the market-leading controller? No. We're not in the game of making controllers. We're in the game of making an open underlay technology which you can make choice on the controller. So hence, a lot of people use ODL, but a lot of people use NSX. And that's going to be our stated strategy going forward, to make sure that we are agnostic to the controller overlay that you wish to buy, because that space still has some way to go. And then the other piece that we have, which I want to draw attention to, is the virtual traffic manager. So this is an industry which comes under the term of NFV, Network Function Virtualization, which I'm sure you've heard about, or hopefully you've heard about, which is when you look at devices, hardware devices in your network, which we call appliances. So a specific device which does one job, we'll refer to as an appliance. You've got to power it, you've got to buy it, you've got to manage it, and they're expensive. There's lots of them. There's IPsec devices, there's firewalls, there's the load balancers, as people refer to them, or traffic managers, dominated by one company. I won't say the name, but it begins with an F. You could probably figure out who it is. Hardware-based, proprietary. You know, as somebody pointed out to me, the world's most expensive PC, because you're spending about 100K on a big one. A lot of money. You can do it in software for about 2K. Now, has it got all the features of an appliance? No, not yet. Do you need all the features like phone systems? No. You don't need all 999 features. But when you look at the deployment options you now have, what is the sense, for instance, of buying a physical a physical load balancer to put in a data center when you have a virtualized environment that might offload to the cloud? You virtualize your data center. Yeah? The hypervisors are moving all around the place. The applications are moving around the place. But you physically got a device here which can only manage traffic in that space. So if you think about NFV, lots of those products have to go virtualized. And the big thing to leave you with was on a security piece, and then I can give you 5 minutes back, was really like the presentation on the perimeter security and how that's going. I know it's very important. We had a really interesting breakfast with Cardiff, one of our good customers this morning, and I think it's a Gartner piece of work, so I'll give you credit for you even if it isn't a Gartner piece of work. But what they said was, 10 years ago, 1 in 100,000 employees of any business or any student, university student, was a rogue plant, was somebody that was trying to get into an industry, get into somebody to steal information, disrupt or do something. 1 in 100,000. And you could pretty much weed them out. Don't think of cybercrime anymore of groups of people in sweatshops trying to break into networks sponsored by certain countries which think that's a good idea. It's now about 1 in 100, and this comes from Gartner and Wells Fargo meeting we had last week. 1 in 100 employees or students is coming in to steal, disrupt, or do something. You can secure your perimeter as much as you want. I don't know if anyone believes that alarm systems stop people breaking into your house. They're a deterrent. The real threat now exists within. So the network has to become a security device as well. And where you'll see a lot of the world going is using machine learning, which seems like quite a complicated topic but actually isn't, to develop the correct algorithms that we can look at and monitor odd things within your own domain. So the last piece of advice is you will see, if anything I'm certain of, there's 3 things I'm certain of. 3 things I'm certain of. The first one is that data will continue to expand because we haven't figured out a way of what we actually need to store. We just store everything. We're getting better at it, but it will continue to expand. The next thing is the world will continue on its march towards mobile. That's an absolute definite. I don't think anyone will see that that will change. And the third thing is that the network will become a critical part of your security infrastructure because threats will move from outside to inside and are already happening. So it's a scary thought. It's a scary thought that 1 in 100 people, literally, I mean, it's not everywhere because it means I think we're a bit better in the UK than other countries, but certain parts of the world, and you guys are competing for students from lots of these parts of the world, you know, we have to think about security holistically in a different way. So, think big, start now. Hopefully you found that useful. Thank you for your attention.